In this tutorial you will learn how to match the body of this character to this body in Cloth Converter tool or Character Converter tool. The techniques shown here can also be used to match any mesh. When you use the Deform 3D tool, in order to do the matching, we first need to click this button and then click this button to set the tool to the Match Meshes mode. In this mode we can use these point matching and face matching functions to match this shape to this shape. Although you can match this character shape to this one directly using these functions, we recommend you to first go to this step, click on it, then click this to set up the shape of character using these parameters to match this body to this body as much as possible, because this will help to get a better results on preserving the mesh topology. In the previous tutorial we have built a shape to match this one, so we can just load that exported shape and don't need to build again. So let's finish. Then let's go to the second step, then click this button to load the shape we built before. Now you see, this one has almost matched to this one, so we just need to use point and face matching to match this shape to this one perfectly. The idea behind point and face matching is first we manually link some points on this source mesh to some 3D positions in the target scene. 3D positions mean they do not need to be points on the target mesh. After these link points are created, what the point matching does is deforming this mesh to match the link point as close as possible and at the same time preserving the mesh topology as much as possible. What the point and face matching does is deforming the mesh to this one to not only matches the linked points as close as possible, also matches the source mesh faces to the target mesh faces as close as possible. Now let's how this process. First let's create some linked points When we create link points, we can create manually. By clicking this button, we select the Points Linked Manually mode. By clicking this button, we select the Points Linked Automatically mode. First, let's go to this manual mode to create linked points manually. Use the right mouse button and click on points such as this point. Then in the target scene, we need to click another point. To facilitate the viewing, we recommend you to change the color mode. Then we click on this one. Use the right mouse button and then click another one. Then click one here. We need to click the key feature points. This one may be clicked in the wrong place. We can correct it in two ways. One is just clicking this point again to delete the pair and recreate. So click to delete the pair and create again. Another way is just adjusting the target point position. To change the position, we must change the shading from solid to wireframe by clicking this button. Because only in the wireframe shading, you can see and click any point, even through the mesh. Let's change this point's position. First, click on the right mouse button on the point and then move. The point will move on the plane which is perpendicular to the view direction. For example, now we show the model in the front view. If we move the point, we move it in the X and Y plane. So let's move it. Then let's turn to another view and move the point. When you move a point, we recommend you to keep the camera projection in orthogonal projection. Actually, we recommend you to always use the orthogonal projection, unless you have special needs. Now let's turn back to the front view. After changing the position, we can set the shading back to solid. Let's click more point. Click on this point, click on this point. If you do not like the size of the red ball, you can change it here. Click on this option. Then change this parameter here. Let's create it. Then when you click on another point, you can see the ball becomes bigger. If it's too big, Let's change it to a smaller one. When you click on the next point, the ball size changes. Sometimes we need to match not only points but also a line segment such as a one from here to here to match the line segment from here to here. So we need to match a few points on a line segment to a few points on another. We can do it this way. First, click right mouse button in the right sense. Click on a point here. Then click on another point. Then go here. Click on the point corresponding to the first point. Then click on the point corresponding to the second one. If you click no, just 2 point pairs are created. Let's click yes. Some point pairs are created. So in this way you can link a line segment to another line segment. Now let's show how to link points automatically in the automatically linking mode. Let's click this button to change it to the automatically linking mode. In this mode, when you use your right mouse button to click a point on the source model, its corresponding 3D point is automatically created. It's a 3D position point, not a point, on the target mesh. It has the same 3D coordinates of the source point in the right scene. Then we can move it. First change shading to wireframe, then adjust it a little to move it to the mesh surface. This automatical point linking is useful when these two models are almost matched and the feature point to be clicked is not clear or obvious. So you can click this one, it automatically create this one. Let's change shading to solid. Let's change color mode to blank white. At this area, the two models are almost matched. So we can just use automatic linking to create a linked point pair. We can also automatically create points using a selected region. Using these two buttons to do this, let's first click to this button. To change to the Edit Faces mode, suppose we want to create some points such as here. The feet, let's select it. And then go back to this Match Meshes mode. Let's move mouse to this button, this one, to see its function. Link selected points automatically. Let's click it. You'll see the selected points are linked automatically. This function is useful when you want to fix a part of the model, keep the part unchanged during deforming. Now let's show how to delete some point pairs together. Let's first clear the face selection. Then select a region containing the points to delete. Then click this button to delete the point pairs. Let's delete all the points on feet. At any time you can save the data of the link point pairs. Using these two buttons, let's first click this one, which saves the data to selected fill, which you can import to restore the point pairs. Let's click the refresh button to clear all the point pairs. Then let's click this button. Then import the file we have just exported. You see, all the point pairs are restored. Let's link more points manually. Let's click this 1 point. 1 point then. Suppose we want to save all the results to the file we just exported. We can click this button to save the data directly to that file without asking to select a file. Let's create some other points we needed. When you create linked points, we recommend you to create points on the feature points such as the crotch point, and this point and end of thess fingers. Let's just do it manually. Let's check the results to make sure they have correct correspondences. Because we are matching the models symmetrically, we can just link points on one side, the left side, and we don't need to link points on the other side. Let's click this one to save the results. Then let's start to do point and face matching. To do it, click this button. Then set related parameters. First, look at the checkbox here. If you want to keep the source model left-right symmetric during deforming, select this box. In this case, you just need to link points on one side. If you do not want to keep the source model left-right symmetric during deforming, unselect this box. In this case, you need to link points on both left and right sides. You can change the iterations, but normally the default value is okay. In each iteration, we first do some few iterations of point matching and then some few iterations of point and face matching together. We recommend you to do only point matching first, and then do point and face matching only after the two models have been almost matched. So now we do not do face matching. Select 0. Do not select these two checkboxes now. They can only be selected finally. You can cancel if you want. Let's click OK to do it. It's finished now. Let's switch color to black too. Check the results. We need link 1 point here. So let's change back to solid at 1 point here. Then do it again. This is an iterative process. In each iteration, you check the results, add or adjust link points, then do point matching and get better results. You can do as many iterations as you want until getting the results you want. Now the two models are almost matched, we can start to do face matching. Now the faces are not matched. So click this one now, change this one from 0 to 1. So in each iteration we do a matching point. Matching and a point and face matching. Let's click OK. because this target model is not perfectly symmetric and we keep the source model symmetric. Therefore, you can see some areas are not matched well. Let's check the ears. They matched on the left side. Now let's add some points on the right side. Then do matching without keeping the source model symmetric. Turn this one off. Match point matching only. Do face matching. Let's check the ears. They are matched. Finally, select the Use Face Point Position Finally option. But do not select the Use Feature Point Position Finally option because we are not sure that the 3D positions of all link points are set correctly. Now the two models are almost perfectly matched. Let's change shading to wireframe and check if there's any gap between the surfaces of the two models. Finally, we save the link points again. Then let's save the match shape to a new file. Click this button. We name the file Body Matched. This is the end of the tutorial. Thank you.